So we've talked about instantiations, we've talked about classes, but in this episode of Pragmatic Software Engineering, we're going to be talking about static contexts, specifically static methods, static variables. Okay, let's talk about if statements. If statements are a fundamental way for us to turn code on and off depending on an input. An if statement consumes a Boolean and has code to run if that Boolean was successful or not successful. In Boolean terms, we would say true or false. If statements can be used in a variety of different ways, but the two branches that I wanted to hone in on were using if statements in a nested way and using if statements in a series way. Now, this, for you hardware guys, is very similar to series and in parallel. What I want you guys to realize that if statements have at its core mutually exclusive conditions. So this means if my input is not divisible by 2, or if my input is divisible by 2, then it's even. If it's not, it's inherently odd. These are two things that cannot coexist. An integer cannot be even and odd. So I want you to imagine cases you need to capture for figuring out how to dress, how to go outside. And it's a winter day. If it's windy, you'll wear a windbreaker. But if it's just cold, you'll wear a sweatshirt. Now, if it's windy and it is cold, you will do something completely different. You will wear a winter jacket. You can see here on the Venn diagram that we're really targeting this overlap portion right here. And you can do the same thing if you have an if statement. So you'll have an if is windy and if is cold, defined if in windy, you'll have a winter jacket case. Again, you use nested if statements to isolate a case. Now you can also use if statements in series. So this is pseudo Java code I've written here on the left. And so we have a postal code and we're asking, is the postal code 1? If it is, then we are in Swingtown. Now we have to explicitly express that the failure case to be 1 has another if statement inside. And that is if the postal code is 2, then it is Kokomo. And if it is not Kokomo, it must be Middle Earth because it certainly cannot fail and be Swingtown. We've already checked that we're Swingtown. We're checking it for Kokomo. We're neither. We must be Middle Earth. So you're quickly seeing how we're starting to put a lot of if statements in our code, or we're starting to talk about designing our code with a lot of if statements. And you'll quickly see that if statements, when they're nested, they quickly get out of hand. It's hard for you to realize what's going on. And in series, the code is very verbose and arguably a little difficult to understand. So we'll talk about this at the end of this video of how we can handle this sort of code hygiene. So let's do our windy and cold example here. We have this concept of windy and a concept of cold, and we have a concept of windy and cold. So with that, what we're going to do is we're going to create two Booleans, is windy, and we're going to set that to true. We're going to have Boolean, is cold, and set that to true. And we're going to create an if statement and say, is windy. We're going to print out windbreaker, and we're going to return to ensure nothing gets run after that. In fact, the right thing to do here is really create another function, a static function as we've talked about, and we'll just have this like figure out what to wear function, and we'll put this code in here. Else, if is cold, we wear a hoodie or a sweatshirt. So now, let's just figure out what to wear. And let me actually extract. Now let's put these as arguments because this will make this code a little bit easier to read. So let's get rid of these. We'll figure out what to wear when it's windy and it is not cold. We should see windbreaker. Let's run it. Now let's change it to be if it's cold and it's windy. Now, just take a second to think what's going to happen here if we run this code. Is it going to return windbreaker or is it going to return sweatshirt? All right, time's up. Let's look. It's going to choose windbreaker because is windy is still true. Now, if we want to figure out the case of when it's windy and it's cold, we need to write some more code in the is windy code branch of the if statement here. And we'll do that a nested if statement. And recall, we can only wear one thing at a time. So we can't wear a windbreaker and a winter jacket. That would just be ridiculous and very unfashionable. So we'll put in if it is cold in the it is windy if statement. And we're going to print out a winter jacket. If I run this without putting a return here, I'll see two things be printed out. And let me show you. The reason is we did not return out of this if statement. We did not stop the function. If I return and run this again, you will see a winter jacket. So let's do all of our cases here. Let's do false. False. And let's do one more. Let's just do one when both are false. And what we can do here is we can just put our default. Oh, actually, you know what? If we do false, false, we're going to wear a sweatshirt because we are not windy. No, actually, we're just not going to print anything. Let's take a look. Yep, see, we don't print anything here. Yeah, because we're not going to wear anything. That's going to be very, very uncomfortable for our friends and family. So we have this if statement here. We have this kind of convoluted, super, let's just say it for what it is. It's really an ugly piece of code. So let's think this through and let's produce our cases and our expected output. So we're lucky here. We actually wrote out all of our cases. And what I like to do is I like to toss out some comments to think about what I really should return here. Until we learn how to test, this is how I'm going to show you how I kind of check my code. So if it's true that it's windy and it's true it's cold, then we should expect a winter jacket. If it is not windy, but it is still cold, we expect a sweatshirt. If it is windy and it is not cold, we expect a windbreaker. And we expect nothing for this. So let's refactor our code to be a little bit more readable. So remember we talked about Booleans and how you can relate Booleans to each other? Well, that's exactly what we're going to do here. I'm going to keep this code at the bottom, and I'll get rid of this stuff so you guys can see this better. I'm going to create these three cases, or these four cases we talked about above. And I'm going to compile my Booleans together. I'm going to say if it's windy and it's cold, I'm going to wear a winter jacket. And I'm going to even use this return. I'm going to copy and paste this because it's easier. Now, I can put an else here, but it's not needed. And let me show you why. If one of these is false, if is windy or is cold is false, then I still need to do some more checks. And it doesn't really matter that I put them in an else. I can leave it be. So let's actually spell out those cases here. So if is windy, we can wear a windbreaker. if it's cold, we can wear a sweatshirt. And now what we can do here is create a default case that looks pretty easy. And you know, if it's not windy, it's not cold, man, I'm wearing shorts and a Hawaiian shirt. Hawaiian shirt. Hopefully I spelled that right. That's right. I should be printing that, not returning it, because our function signature is void. So actually, yes. So this return isn't even needed. I'm going to delete this code, and now I've created something that's a little bit more verbose, but something that is certainly easier to read. Let's run this code. Cool. I'm going to change this so that I'm right. Now, you'll see here that we are using those else statements. Let's put those else statements in just to show you guys how this works. Let's run it again. Oopsies, sorry. Gotta get rid of this. What's else here? See, this is a great way to show you that this is not a great way to write code, because I'm even having trouble trying to break the code. So this is the same thing here, and if you look at this, if it's not windy or cold, or if it is windy and cold, then we print a winter jacket. Else, if it's windy, else if it is windy, we wear a windbreaker. Else, if it is cold, we wear a sweatshirt. And then, you know, I could put another else here. And now I'm really using else's to make this code work the same exact way, but honestly, kind of ugly. See, we're returning out, all these things are mutually exclusive, these cases we have. You can't have any of these cases, you can't have multiple of these cases happen. One of them has to happen, and it's mutually exclusive for every other case. The reason being, we have this return here. This stops the execution of the code. So we could write our code with all these else's, or we could go back to what we just had. And I think you guys get it, but I'll let you be the judge of what you think is much easier to read and much easier to work with. So I know we've worked so hard on this example, but I want to put one more thing here. There's actually another case. And what we're going to do is we're going to expose a case where our code can fail. Here, we're not going to pass false or true. We're going to pass null. Now, if we pass null, this application is going to probably die. Let's run it. There's a null pointer exception. Here's one thing that I love using if statements for, and I think is super critical. It's called short circuiting. If we know that this is going to end poorly, passing nulls into this, some input is not valid, or we know this is going to be a waste of computation cycles or programming runtime, we can create something called a short circuit. And a short circuit is basically where you enumerate out a case where you know it's going to be computationally not worth it, or you'll create an exception. In our case, if is cold is null, or if is windy is null. If either of these is null, we need to just bail immediately, because we're going to get some sort of issue. And to show you that how that it really works is, I'm just going to say, we bailed, he gave me a null. And if we run it again, we don't see an exception. In fact, we just see, we bailed, he gave me a null. Short circuits are super helpful for working with data services like databases and web services. It's also really helpful to prevent exceptions and code that is expensive to run from running.